All right, so now we're going to put all of these concepts together. And the thing to remember is that if you are given a original function, so just f, there's no prime involved, what you're graphing is a point. So the original function represents a point. So when you're looking at this where it just has f of 3, that is going to be our 3 comma 4. So it is a point, a coordinate on the graph. Now, in comparison, when you take a look at the first derivative, so if you're given the first derivative, remember that the first derivative tells us information about where is the function increasing or decreasing. So if the first derivative is positive, then that is going to tell us that it's increasing. And if the first derivative is negative, then it's going to tell us that it's decreasing. So when they give you information where they're saying f prime of 3 is equal to 4, that positive is going to tell us that this function is increasing at x is equal to 3. And again, that x equals 3 is coming from the parentheses 3. Meanwhile, if they give you information about the second derivative again tells us concave up and concave down. So if the second derivative is positive, that's going to tell you it's concave up, whereas if the second derivative is negative, it will tell you that it's concave down. So here when they tell us that f double prime of 3 is equal to positive 4, that's telling us that it's concave up at x is equal to 3. So you'll see questions where we're trying to put the first derivative and second derivative together. So for example, here we have a graph and they have this big bold point. You'll notice that at this point here, the function is concave up. So again, at that point, it looks like a U-shaped graph, so it'd be concave up. Also at that point, you'll notice that you're going up the hill, so it would be increasing. So relating that back to the derivative, that would tell us that if it's concave up, our second derivative is greater than 0. And if it's increasing, our first derivative is greater than 0. So at this point, we know that the second derivative is greater than 0, first derivative is also greater than 0. Now, if you compare that to a point over here, you'll notice that on that point, you are concave down. So here, because you are concave down at this point, that would tell us that the function's second derivative is less than 0. And you'll notice that at this point you are increasing, you're going up the hill. So because you are increasing, that would tell us that the first derivative is greater than 0. Now, comparing a little bit further, if you look at this point right here, you would say that the function is concave down. It continues to look like that upside down U. So that means the second derivative is less than 0 and it is decreasing. It's going down the hill. So because it is decreasing, that would tell us that the first derivative is less than 0. So again, you can have different points where the first and second derivative are either positive or negative, depending on concavity and increasing and decreasing. Another thing to remember is that if your derivative is equal to 0, that is actually a horizontal tangent. So if it's strictly increasing or strictly decreasing, it will be strictly positive or negative. But when it's 0, that actually represents a horizontal tangent on the graph.